Okay, these are your notes for Chapter 3, Section 2, Structure of an Atom. These up here are just your objectives. You don't really need to write those down. We will go through them. All right, for the structure of an atom, you already have atom as a vocab word, so don't worry about putting this one in your notes. It's the smallest particle of an element, but it has to retain the chemical properties of that element. You will need to write down nucleus in your notes. It's not going to be on your vocabulary word, so make sure you write down nucleus. It's a very small region at the center of the atom. In a minute, I will draw you a diagram to look at. The nucleus is made up of at least one positively charged particle called a proton, okay, and then also neutrons, which are neutral. So again, you'll probably need to jot that down in your notes unless you think you can remember it. Kind of up to you. I know this should be old material that you are reviewing, but remember, in the nucleus of an atom are protons and neutrons. Surrounding the nucleus, like orbiting the nucleus, are the electrons. And of course, they're negatively charged. They're also much smaller than protons and neutrons. All those together are called subatomic particles. And again, you will want to write these for your notes. These are not bolded words. They are italic words, and so they are not in your vocabulary. You'll want to jot those down if you want them for Friday. Okay, really quick, just to remind you, and like I said, this should be complete review. You guys have done atomic structure before. In the middle, we have protons and neutrons, okay? That means some of these have a positive charge. These are positive. And then some of them have no charge, okay? And then orbiting out around here is where our electrons are. And if I have 1, 2, 3, let's just say 4 protons in the middle here, then when the atom is neutral, I also should have 4 electrons, okay? And just for kind of knowing what's coming in next, if I want to look up which atom this was that has 4 protons, then it must be beryllium. Because beryllium has 4 protons. You can tell that by its atomic number. Okay. On this chart, you're definitely going to want to know just the charge. See these little particles, electron, proton, neutron. You want to know the charge of each one, of course, just neutral, +1, -1. But something else you need to write down, don't worry about mass number. I want you to write down the relative mass. Okay, that's in AMU, and that's so that you can clearly see that a proton and a neutron are both very close to 1 AMU, but an electron is a fraction of that. It's not even half. It's teeny tiny compared to these two. Okay, so electrons are much smaller than protons and neutrons. All right, also for your notes, you're going to want to know that the cathode ray discovered the electron. It was an experiment that they did in the late 1800s. The rays were composed of negatively charged particles that they later discovered were electrons. So definitely want this for your notes. You're also going to want to know that J.J. Thomson, or Joseph John Thomson, you can abbreviate J.J. Thomson. You'll see it written like that a lot. He's the one that came up with this cathode ray experiment that eventually led to the discovery of electrons. You also will want to write down that Robert Millikan's oil drop experiment measured the charge of an electron. Both important information that you'll see on your quiz. You're going to want to jot that down. Okay? This is just a diagram of the cathode ray. You don't really need to write that down, just for you to look at. Okay. Again, you need this information. It's very important. You'll probably have some sort of short essay question asking, I'm going to ask you to describe Ernest Rutherford's experiment and exactly how it worked. So Rutherford did the gold foil experiment. And what that eventually led to was the discovery of the nucleus. Okay. But I don't want you to just know that he discovered the nucleus with the gold foil experiment. I also want you to know how that experiment kind of worked. Okay. So what he did was he set up this, he would shoot alpha particles out of this instrument here. And alpha particles are just positively charged particles. Okay. And he was shooting them through a sheet of gold foil. Well, gold is an atom, right? And, he expected that some of them would bounce, kind of randomly bounce back, because at this time they thought that the protons and electrons were just distributed evenly throughout an atom. Okay, so he thought that at random he would have these bounce backs from these whenever they hit positive particles. But what actually happened was most of the alpha particles went straight through empty space. And every once in a while, there would be a very small deflection one way or the other. And then at a very, very every once in a while, he would get one that would come straight back at the ray. So with that information, what he, discovered was that the atom was actually not evenly distributed, protons and electrons all throughout it, that it had this dense center right here that was made up of positive particles. And that's how he discovered that the protons were all densely located into the center of the atom and not scattered throughout with the electrons. And this is another good picture showing you that. You see, he expected these rays to kind of bounce back randomly, but here, look, here's your atom. That's all empty space. So most of them went straight through, and every once in a while when they would hit the center, they would deflect. You need to be able to explain this experiment to me on paper. Okay. Atoms are made up of protons and neutrons. I feel like we already took these notes, so you may not have to write that down again. It has a positive charge. We already said that. I feel like there's not much to write down here. We've already covered this. You should already have this in your notes. This one right here, we haven't talked about this bullet number 3. It's old material, but remember that atoms are neutral because they are made up of equal protons and electrons, equal amounts. So atoms are electrically neutral. Okay, don't really need any of that. We've already talked about all of that. And we're not going to go into nuclear forces. You have this in your vocabulary, so no need to write any of those either. Go ahead and jot down that a picometer is a unit for the size of atoms. Sizes or radiuses of atoms. A picometer is the unit for that. So don't write down everything. Just write down that a picometer is the unit for the radius of an atom. All right, and that is the end of the section 2, chapter 3 notes.